Okay, off we go. So this data set has got a few columns. It's got row number, customer ID, surname. So what we're looking at is a data set of a bank. Of course, it's all fictional. It's not a real bank, but it's very realistic. And here we've got a snapshot of, if you scroll down to the bottom, is going to be 10,000 customers. So 10,000 rows in this data set. And what the bank did is they measured some things about these customers, right? Why did they undergo this whole thing? And what's the challenge here? Well, the bank has been seeing unusual churn rates. So churn is when people leave the company, and they've seen customers leaving at unusually high rates, and they want to understand what the problem is, and they want to assess and address that problem. And that's why they've hired you to look into this data set for them and give them some insights. And how did this data set come to be? Well, 6 months ago, the bank said, all right, there's a big problem. We got to take a sample of our customers. By the way, this is a sample. 10,000 is a tiny number for this bank. This bank has millions of customers. It operates, this fictional bank operates in Europe, in three countries, France, Spain, and Germany. And they have lots and lots of customers. So what they did is they took this sample of 10,000 customers, and they've measured 6 months ago everything they knew about them: their customer ID, their surname, credit score, their geography, their gender, their age, their tenure, so how long they've been with the bank, the balance of the customers at that point in time, the number of products they had at that point in time. So, a number of products is things like how many products do they have? Do they have a savings account? Do they have a credit card? Do they have a loan? Did the customer have a credit card or not? So there's a yes no flag. Is the customer an active member? Another yes no flag. Active member can be measured differently by different organizations. It could be whether or not the customer logged into their online banking in the past month, whether they did a transaction in the past 2 months, or some other measure like that. And estimated salary. So the bank doesn't know the salary of the customers, but based on the other things they know, they could estimate a salary for that customer, and they also gave you this information. So 6 months ago, they measured all of these things and said, all right, so for these 10,000 randomly selected customers, we're going to just watch them. So we're just going to wait 6 months, and 6 months down the track, we're going to check who of those customers left and who of those customers stayed. And that's what this column exited represents here. It tells you whether or not the person left the bank within those 6 months. So this person over here, sometime within the 6 months, he left the bank, and as of a couple of days ago, he's no longer with the bank. This person over here, on the other hand, is still with the bank. So there's a zero here. This person left the bank, this person stayed, and so on. So if you see a 1, that means the person's no longer with the bank. A 0, the person's still with the bank. And your goal is to create a geodemographic segmentation model to tell the bank which of the customers are at highest risk of leaving. What I wanted to mention today is that for a lot of customer-centric organization, this is going to be valuable. So I've done this personally. I've done this so many times. It is such a value add to any customer-centric organization. So whenever an organization deals with customers, this is a lot of value add. And then the other thing is that this skill that you're going to learn is very transferable. It doesn't have to be for a bank, it doesn't have to be for churn rates. Geodemographic segmentation models can be applied to millions of scenarios. So here, for instance, even in a bank, the same scenario could work. Should the person get a loan or not? Should the person be approved for credit or not? And once again, you'd have a binary outcome. So based on prior experience, you would know whether or not a person is reliable, and you'd build a model and say which people are more likely to be reliable and which people are more likely to default. And that could govern the bank's decision on whether or not to give loans. This could be in terms of fraudulent transactions, not even in a bank, in a different financial institutions. You could find out which transactions are more likely to be fraudulent, which are less likely. There's lots of scenarios where you could apply a geodemographic segmentation model, and it doesn't even have to be geodemographic. So whenever you have a scenario, when you have a binary outcome and you have lots of independent variables, you can build a proper robust model, and that will tell you which factors influence your outcome. So you can apply this knowledge that you're going to learn in any kind of scenario where you have a binary outcome and lots of